Okay, welcome to MCR3U. We're just going to be doing some practice questions. I'm just going to be going over the stuff that you learned about domain and range. And this is kind of just a video to help you study, and if you had any questions, clarification on that. So we're going to start with domain and range. So domain and range. Okay, so starting off, we'll start off with defining. We'll start off with domain. So domain is defined by all possible values for x in a function. That basically just means when we're referring to the domain of and the range of a function, we're talking about any possible values that can exist. We'll go more into this as we do examples, but basically you need to consider if there's any physical restrictions, if we're talking about something in the real world, or if there's any numerical restrictions on a domain. Otherwise, for that most part, everything will be x, such that x is an element of all real numbers. That is to say that if x is an element of all real numbers, x can be any number on the number line from 0 to positive infinity and negative infinity, 0 to negative infinity in the opposite direction. So we'll do one example, and then we'll talk about what this means in terms of as it gets more complicated. So we'll start off with example number 1, right? That is, what would the domain be for y equals 2x plus 3. So there's a few simple steps to solving this problem. The first step is always going to be determine what type of function it is. So if we look at this function right here, the parent function for this function is going to be y equals x squared, which is a linear function. If you look at this, this is y equals mx plus b. Okay, so this is a linear relationship, which means that we're going to now just write that down, linear relationship, right? After you figure out what type of function it is, we're going to move forward and try to just graph this function, if you can. So let's graph y equals 2x plus 3. So I'm just going to draw a graph over here. Right, we're going to go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 over 1, 2. All right, and so we're going to go up to 3 because the y-intercept is 3. Go up by 2 over 1, down 2 over 1. This is just basic graphing of a function because the rise over 1. And I'm just going to draw that line in. Right? This is a linear function. Now what you're going to do is you're going to look at your function. When you're determining the domain, you want to see all the x values, so that's going to be to positive infinity, and this is going to be to negative infinity. If you look at these values, this graph can continue forever and ever and ever, in this direction, which means that it can continue forever and ever in the direction of positive infinity. So I just gotta fix that over there. It can continue forever and ever in the positive infinity direction, and it can continue forever and ever in the negative infinity direction as well, which means that in this situation, x can be any number from negative infinity to positive infinity. Therefore, x can be any real number. And that's how we determine the domain. Okay? And then you just write it down. So that was a pretty easy one. We're going to move on, try to do something a little bit more complicated. So our second one is example number 2. Y is equal to square root of x, right? So the first thing you're going to do is you're going to think. Think about this. What restrictions is x going to have in this situation? What can x not be? So I just want you to think about that for a minute. And then we'll figure this out together as soon as I write it down. Okay, so in this situation, x cannot be a negative. I'm just going to find a better pen than that one. Cannot equal any negative number because square root of negative 1, negative 2, negative 3 is undefined, i.e. not possible. Okay, so if x can't be any negative number, that means x must be greater than or equal to 0. This sign just means greater than or equal to. That means that x can be 0, 0.1, 0.3, 1, 2, 3, 1,000, anything that's not a negative number and is greater than 0. Right? Then if you also want, you can graph this function to find the domain. Right? So that's starting here. If it's going to be greater than 0, that means all my x's going this way are going to be positive x. Which means that I can't have a negative x here, right? I can't have a negative x here. And so my domain is going to be domain x such that x is greater than or equal to 0. X is still an element of any real numbers, just has that one restriction on it. Right? Does that make sense to everyone? Hopefully it does. All right, so moving on. We're going to do something, again, a little bit more complicated. So I always like to start off with the easiest example first. Start off with a linear function that has no restrictions, a function that has restrictions, which is the positive square root function. And last but not least, we're going to move on to a real-world example. So this is example number 3, right? This is more of a word problem. What is the domain I'm just going to write the question down and then we'll talk about it. So we're going to be talking about the domain of a function that represents the area of a triangle. In this situation, the independent variable is going to be x, which represents the width of the function, right? Because our width is dependent on what our side lengths are. So that's why it would be the independent variable, right? And the dependent variable in that situation, y, represents the area. So this is our dependent variable. Because we're talking about domain and range, another way to think about domain is domain always represents the independent variable. Because x always represents the independent variable. All right. So, like I said, there's a few steps to solving this problem. The first step is always going to be 1. You're going to look at your problem and be like, okay, so what are some physical restrictions that can possibly exist on x? Sorry, I didn't even give you the formula though. So the formula is going to be y equals negative x squared plus 8x. That's our formula that we're working with, right? So again, we're going to look at this. Are there any physical restrictions that exist on x? It's kind of hard to figure out from the equation, but if we just think about this logically, right, what can x possibly not be in this situation? Your x can't be less than 0. You can't have a negative width because it represents a width. So we're just going to write this down. Therefore, x must be greater than or equal to 0, because you can have a 0 width. It wouldn't make any sense, but you can, right? So greater than or equal to 0. Then it asks us, it's representing the area. So also your y must be greater than or equal to 0, right? You can't have a negative area, so your y must be greater than or equal to 0, right? You can have a negative area. You can't have a negative, sorry, you can't have a negative area. You can have a 0 area. It wouldn't make any sense, but you can. So when we're talking about x can't be greater than 0, y can't be greater than 0, and this is a quadratic function because of this 2 over here. I just wanted to make that clear. That's how I know what it is, right? That's why I know what it is, because it's the 2 up here that represents that. So if negative x plus x is our function, we want to find where, first of all, the a is, I'm just going to draw this out here. So we're just going to look at this, we're just going to draw a rough sketch. So this doesn't have to be accurate. We're just going to draw a rough sketch because it's always easier to just look at the graph than it is to try and visualize this kind of stuff in your head without really anything. So we know that x must be greater than 0. We know that it's going to be facing downwards because we have a negative there. So it's going to look something like this, our function, right? So what we want to know is that where can my x's not exist? Or where can my function not exist? So very easy, you can't have any negative x's. So we're just going to cross this entire part out. Our function cannot exist here, right? So we already said that because x has to be greater than 0. Our function can also not exist in this realm here. Why? Because you can't have a negative y. So our function needs to exist between these 2 points. Lucky for us, we actually know how to find these 2 points on a graph. This is where the function hits the x-intercept. The other way we say this is where our x's are 0, right? So if I'm given this function, I can find the zeros of this function by saying y equals, I just have to factor. So I factor out the negative x, right? My x squared turns into an x. If I factor out the x from here, it becomes x minus 8, right? Now I know that my root here is going to be 0, right? Because when negative x equals 0, divided by negative 1, divided by negative 1, x is equal to 0, right? And then if I want this function to equal 0, my second bracket needs to also equal 0. So x equals 8 equals 0, x equals 8. That means that my next root here is going to be an 8. So that basically means that my function, the only x values that I can have that exist in this function, have to fall between 0 and positive 8. So my domain becomes, I'm just going to write that here, therefore x must be between 0 and 8. Oops, sorry, it's not a very good looking 8. 0 and 8. So my domain is going to be x such that x is going to be greater than 0. So I'm going to write 0 over here because I'm going to put the x in the middle, and then 8. So this is how I like to write this, right? Because now x is physically between 0 and 8. So if x is between 0 and 8, that means that x has to be greater than 0 and less than 8, right? So if you look at this,